Hello. In this video, I will do an optimization word problem involving an open box. So this is example 3, optimization word problem. So it says here, a manufacturer wants to design an open box having a square base and a surface area of 108 inches square. What dimensions will produce a box of maximum value? So the first step in this optimization word problem is draw the best image you can. So it says we have an open box or an open cube with a square base. So you could just draw a regular cube. How does a cube look like? It would look something like this. No, it's not perfect. Ah, well, you get the idea. I'm trying to make a perfect cube. But okay, so let's pretend the base is a square, so that means all sides are the same. And this, we don't really count this side because it's like an open cube, an open box, right? So what do we know about squares? Square bases, they're all the same. So this length is equal to this length is equal to that length and equal to that length. So maybe we'll call this length x. So this length also should be x. And then maybe we'll call this height because, yeah, let's call this height y. Okay. So we did step 1, we draw the best image, label our variables. Step 2 is somehow find two equations. So they say that surface area is 108 inches square. So 1 Earth is a surface area. It's basically you add up all the areas except for the this open box, right? I mean this open side because we that's not really included. So how do we find this? Well, we know that the square, the area of a square is x squared because x times x is x squared. And then maybe what about the, so we're taking the area of all sides except for this side. So what about the area of this side? Well, this length is x, this height is y, so that's xy. And there's 4 of them, right? We don't include this one, so there's no, we're not including this length, this base. So there's 4, like 4 faces, so it's gonna be 4xy, okay? So the base is x squared, the other faces, so this face right here, I'm going to use, I don't know if you can see this, use red. So this, I'm talking about this face right here. It is x times y, x, so that would be xy, and then there's 4 of them, right? Because we exclude the top. So that's why it's plus 4xy. And that is equal to 108. So I guess you can say, let's rewrite this as x squared plus 4xy equals 108. Okay, so I believe this will be our first equation. Maybe I should box it. And what would be our second equation? So if we look back, what dimensions will produce a box of the maximum volume? So what is a volume of a cube? It's length times width times height, right? So this would be our length, this would be our width, and then this would be our height. So volume is actually going to be x squared times y. Okay. So this is my first equation, this is my second. That's it. That's what we did. We found our 2 equations. Next step is what we're going to substitute. We're going to get one of the variables and substitute into one of the equations. So what will we do? So what are we trying to maximize? The volume is what we're trying to maximize, right? And this would be like our secondary. So I think it's best if we use the secondary and we solve for y. What if we, I think if we solve for x, it wouldn't work. If we solve for x and then plug it back into this, it wouldn't work because there's two x's. So it's best to solve for y. So how do we solve for y? So I'm going to first subtract x squared from both sides. So I get 4xy equals 108 minus x squared, right? And then what I'm going to do is solve for y. So I'm going to divide both sides by 4x. So you get y equals to 108 minus x squared over 4x. Okay, so now I'm going to substitute into the volume so we can have it in terms of x. Should we clean this up? It doesn't matter. So I'm just gonna, yeah, I can get away with it with this. So I'm gonna substitute back into this. So it's gonna be x squared times y, and we said y is this whole thing. So if you kind of like clean that up a bit, you kind of clean this up, you're gonna get volume equals 27x minus 1/4 x cubed. Okay. Okay. So once I did that, what's the next step? Take the derivative of this equation, set it to 0, and solve for x. And hopefully that'll be your we're trying to find the critical values. So um, maybe we'll take the derivative. We don't have to take it implicitly. So it's this, you could just say v prime, right? Or no, I think we should. So let's take the derivative, everything in respect to x. So in the left side, what's the derivative of v in respect to x? It would be dv dx. What's the derivative of 27x in respect to x? It would be 27. What is the derivative of negative 1/4 x cubed? It would be, I believe it would be negative 3/4 because it's power rule, x squared. Okay. Then what we're going to do is set dv dx to 0. And we're going to just solve for x. So how would I do this? Maybe get rid of the fraction by multiplying both all three sides by the LCD, which is 4. Okay. So 4 times 0 is 0. 4 times 27 is 108. Yes, it's 108. 4 times negative 3/4. The 4's cancel, so you're left with negative 3x squared. Okay. Then I'm going to solve for x. So I'm going to subtract 108, subtract 108. You get negative 108 equals negative 3x squared. Solve for x. So I'm going to divide this by negative 3, divide this by negative 3, and I get 36. Take the square root of both sides. You get x equals plus or minus 6. Now, it just wouldn't make sense to use a negative 6 because it just wouldn't make sense as our length to be a negative value, right? So I think it's just best to use the positive 6. Okay. But we got to verify that is an actual, that will actually give us a maximum value. So how do we do that? We in a number line, right? So put 6 here, and then we're going to put it back into, we're going to test region 1, region 2, and we're going to plug those values back into dv dx. So dv dx is 27 minus 3/4 x squared, correct? So let's test region 1. I need a number less than 6. Maybe I could use, I don't know, 0. So this would be 27 minus 0. That would be just be 27, right? I don't care about the number. It's just I care about the sign. So 27 is positive. Let's test region 2. I need a number greater than 6. So maybe I could do 7. So that's -9. So that's minus. So if you look at our sign chart, we have a positive and a minus. So remember when we do curve sketching, plus and a minus means you have a local max. So this just proves that 6 will give us a maximum volume. So the question says what dimensions will produce a box of maximum volume? So they only want the length. So we know that our x is 6. Now, how do we find y? So if we go back here and plug in our x value, right? X value is 6. That's 2. And then 4 times 6 is 24. Does that even come out nicely? 72 over 24. Yes, it's 3. Okay, so that means our x is 6 inches and then our y is 3 inches. Okay, or 6 by 3. Okay, so that wraps up for this example. This is example 3, optimization works.